Okay, in chapter 4 we're going to be looking at exponential functions. Now, exponential functions are functions where you take a constant number and you raise it to a variable exponent. So most of the functions we've studied thus far in this course involve a variable raised to some power, like f of x equals x squared, or g of x equals x to the 1/2, or square root of x. So these functions have variable bases and constant exponents. Today we will examine functions where a constant is raised to a variable power, i.e. functions where the constant bases are raised to variable exponents. And definition 4.1 gives you just one example. It says that if b is any number not equal to 1, then the exponential function with base b is b raised to the xth power. So the thing that's changing there is the exponent. And so in example 4.1, we're asked to fill out the following table and plot the graph of y equals 2 raised to the x. And so in this table you can see that the first row has x equal to 0, y equal to 2 to the 0, or 1, and so the point is 0, 1. So I'll plot 0, 1 there. If I plug in x equals 1, I get y equals 2 raised to the 1 power 2. So I get 1, 2. So 1, 2 is a point on this graph. If I plug in negative 1, then I get 2 to the negative 1, or 1/2. So that's negative 1, 1/2. And now I need to keep filling this out. So I'll get, if I plug in 2, I get y equals 2 raised to the 2th power, or that's 2, 4. 2, 4. If I plug in negative 2, I'm going to get y equals, what would that be, 1/4? Because that would be 1 over 2 squared, which is 1/4. So that would be negative 2, 1/4. If I plug in 3, I'll get 8. So 3, 8 should be up here somewhere. And then finally, if I plug in negative 3, then that's negative 3, 1/8. And so you can kind of see here that the graph looks something like this. It's a function that starts off really, really small and then grows really, really big really, really quickly.